Hello and welcome to Crazy Math Productions. Today we're going to continue the concept of quadratic equations and inequalities. We're in the unit of quadratic equations and inequalities, also looking at radical expressions and the relationships between them. Now, what we're going to do today is extend the concept of graphing quadratics, and now we're going to look at quadratic inequalities. So really, nothing completely new if you've followed Crazy Math Productions. But what we're going to do is we're going to take several of the concepts that we've already seen and sort of meld them together. Now, the first thing we need to do is to make sure we know what exactly a solution is. Now, a solution to an inequality is something that's going to make it true when we plug in for the x and the y. Now remember, this is the x and the y. Make sure, especially with these, that we're going to plug them in parentheses. That's very important. So 10 in parentheses is greater than or equal to 2 onto 2 squared minus 2 plus 9. And now we don't need those parentheses. We must do the exponent first, then multiply. Eight minus 2 plus 9. 8 minus 2 is 6, plus 9 is 15. And we just have to ask, is this true, yes or no? Well, no. If you look on the number line, 10 is definitely to the left of 15. This is saying it's to the right or right on top of 15. So no, this is not true. So if we had the y is greater than or equal to 2x squared minus x plus 9 graphed correctly, this point, 210, would not be shaded at all. It would not be a solution. Okay, let's try one more time. X and y. Y is less than -1 quantity squared plus 6 onto -1 plus 12. And we just work this out. 6 is less than 7. Yes, this is true. You can look, this is to the left, looks like a little L. To the left of 6 is to the left of 7 on the number line. So yes, this would be shaded if we were to graph it correctly. Now here are some steps. You could pause to look. But we're going to go straight on. Now, a couple things to remember. If you've followed Crazy Math Productions, you know that we do things with the young man who opens his mouth and says many unwise things. And the young man has a young man beard, not quite filled in all the way. But an old man who has little wrinkles under his eyes is wise and keeps his mouth shut. The old man has a full old man beard. Also, we need to remember that you can, when you eat the X, you hit the dex, that is, you go down. Eat the Y, go to the sky. It's a good rule of thumb. Now, all of this will apply to what we're doing here. Now, we also have to keep in mind that this is following the general trend of y equals or y something. Ax squared plus bx plus c. The standard form still applies, as does x equals opposite of b over 2a, which will form the x-coordinate of my vertex. So first of all, we need to find the x-coordinate of the vertex that's going to form the center of my table of values and the center of my graph. Now, x equals opposite of b. B is 6 over 2 times a. That's 2 times 1. So the opposite of 6 divided by 2, or just simply -3. And -3 going up is -2, going up again is -1, going down is -4, going down is -5. And we're going to simply plug this in. Now, for the moment, I'm going to pretend it is not an equation, but I'm going to pretend like this is an equal sign. It's not. In fact, I'm just going to leave this blank so I don't try to confuse myself. But I'm going to pretend like it's an equal sign just to get the basics down here. I just need to find the skeleton of the quadratic equation here, the parabola that I'm going to graph, and just see the 5 basic points, and then I'll know what to do from there. something squared plus 6 times something plus 2. Let's plug in negative 1. Negative 1 squared is positive 1. That's negative 6 plus 2. 1 plus negative 6, negative 5, plus 2 is negative 3. Plug in negative 2. Negative 2 squared is positive 4. 6 times negative 2 is negative 12. 4 plus negative 12 is negative 8, and plus 2 is negative 6. And we're going to plug in negative 3. Negative 3 times negative 3 is positive 9. 6 times negative 3, negative 18. 9 plus negative 18 is negative 9, plus 2 is negative 7. Now, if this has worked correctly, then what I'm going to do is to have some symmetry here. We should have negative 6 in this slot and negative 3 in this slot. And let's see, I'm going to check just one of these points to make sure, just as a little bit of insurance. Negative 4 squared is positive 16. Negative 4 times negative 4. Plus 6 times negative 4, negative 24. 16 plus negative 24 is negative 8, plus 2 is negative 6. And now we're going to, since this did work out, the symmetry is going nicely, we can go ahead and assume that this is negative 3. Now I'm just going to graph these 5 points, negative 1, negative 3, negative 2, negative 6, negative 3, negative 7, negative 4, negative 6, and negative 5, negative 3. Now we get to the real business, which is, now that we have our skeleton, we need to know, is it a young man line or an old man line? Well, this is, you can see, this is the young man. He doesn't have a little wrinkle under his eye. So this is going to be the, not quite the full beard. Some students do have a hard time drawing this, so they actually will draw the curve and then erase little segments to get the dotted line going. I'm going to try my best to see if I can graph it with the dots. There we go. And now comes the tricky part. I want you to take your finger. I want you to put your finger on, ooh, my hand kind of split up here. Take your finger, put it on the vertex. Now think, eat the X, hit the dex, eat the Y to the sky. Now this little alligator is eating the X, so we're going to hit the dex. So we're going to go down below the vertex. Put your finger on the vertex, go below the vertex, we shade there. Now that we have done that, are we inside sort of little cup here or outside the cup? Well, we're outside. So now I can go back in and say, okay, well, we're outside now. But I don't want you to do that until after you've gotten that initial bit, because you have to look, the easiest and most effective way is to look from the vertex, from the perspective of the vertex. So vertex, we're going to eat the X, hit the dex, go below it. It's below the vertex, and so now we know it's all around in the different places. And that's the first graph. Now, if you feel comfortable, you can go ahead and try number 2, pause the video, and see how you do. Let's see how you did. First things first, we're going to look at x equals the opposite of b over 2a. The opposite of negative 4 over 2 times 2. The opposite of negative is going to be a positive. That's going to be 4 divided by 4, or positive 1. That's going to form the center of my vertex. I'm going to go up 1, up 2, down 1, down 2. And so now we're going to go from there. We're going to plug these values in. Again, I'm going to pretend it's an equal sign. It's not. It's definitely not. But I'm going to pretend just to get the skeleton, the first 5 points of this function. So 2 times parentheses squared minus 4 times parentheses plus 3. All right, so we're going to plug in probably a 0 first. 0 is very, very easy to work with. This is 0, that's 0, plus 3 is 3. That was easy. And plug in 1. Remember to exponent first, do the power first. 1 squared is 1, times 2 is 2. 4 times 1 is 4. 2 minus 4 is negative 2, plus 3 is 1. Let's plug in the 2. Well, I'll tell you what, let's go ahead and plug in the negative 1. I just want to go ahead and plug in the 0 since it's so easy to work. Negative 1 times negative 1 is positive 1. Negative 4 times negative 1, positive 4. 2 times 1 is 2. 2 plus 4 is 6, plus 3 is 9. And now we just need to make sure, get a little bit of insurance, and see that the symmetry is going to hold. So we're going to plug in a positive 2. 2 squared 4 times 2 is 8. 4 times 2 is 8. 8 minus 8 is 0, plus 3 is 3. And you can see the symmetry is holding nicely, so we can assume that this is going to be 9. Now we need to graph those points. Negative 1, 9. That's going to be interesting. Zero, 3. 1, 1. 2, 3. 3, 9. And now we have to do our real work, which is looking to see whether it's a dotted line, solid line, and where to shade. Now, this is the old man. You see a little wrinkle, old man. He should have a full beard, which, by the way, means that as you go through, any points that you put that are on the line will be solutions. Whereas in this example, since it was a dotted line, any points that you would pick actually on the line, for example, negative 1, negative 3, that would not be a solution, but just to the right of it would be. Okay, and again, let's see if we can get the amazing drawing of my hand here. Now, put your finger on the vertex. Now, it says eat the y, so to the sky. So we're going to take finger on vertex, go to the sky. So we're going up here. We're shading above. Are we inside or outside at this point? We're inside. So we're going to graph inside the parabola in this sort of infinite U, if you will. Okay. And last one, try on your own. Pause the video and see how you do. Okay, let's see how you did. X equals, wrong pen. X equals the opposite of B over 2A. That's negative 4 divided by negative 4, which is positive 1. That will be the center of my table of values. I go up 1, up 2, down 1, down 2. Plug it in. Y something negative 2, something squared, plus 4 onto something plus 3. Let's plug in, let's just go in order this time, don't want to confuse you. Plug in negative 1. Negative 1 squared is 1. 4 times negative 1 is negative 4. Negative 2 times 1 is negative 2. Negative 2 plus negative 4 is negative 6. Negative 6 plus 3 is negative 3. Plug in 0. I love plugging in 0. That's 0. That's 0. Plus 3 is 3. plug in 1. 1 squared is 1, times negative 2 is negative 2. 4 times 1 is 4, plus 3. Negative 2 plus 4 is 2, plus 3 is 5. And if everything goes according to plan, we should have symmetry. 2, it should be 3. That's next point, if we've done this correctly. So this should be 3, this should be negative 3, if I've found the vertex correctly and I've plugged everything in correctly. Now 2 squared is 4. 4 times 2 is 8. Negative 2 times 4 is negative 8. Negative 8 plus 8 is 0, plus 3 is 3. So you notice the symmetry is holding. This is good. And this will be negative 3. So we have negative 1, negative 3, 0, 3, 1, 5, 2, 3, and 3, negative 3. Okay, so that forms the basis of my curve of the quadratic graph or the parabola, depending on your choice of terminology. This is the old man beard, so it's a full beard. Make sure not to have a corner there. This is a fully differentiable curve, which means it should be no corners. Okay, so in this case we have the old man beard. Now again, take your finger. Where is it? Oh, there it is. Put your finger on the vertex. Now it's eating the X. We should hit the X, go down. So we should shade in that direction. Now ask, are you inside or outside that little U, or inside it? So shade inside. Of course, that will shade forever in that direction down. Well, that will do it for Crazy Math Productions for today. Thank you so much for watching.